Welcome to another video of the Mr. Robot phishing simulation. Today we'll be taking on the role of Mr. Elliot Anderson, a cybersecurity analyst working for SIEM, a managed security service provider. Today we'll be detecting the phishing actions that we performed in our red team role as Mr. Robot. Without further ado, let's get started. Now we are going to analyze the activities using Splunk. Before we get started, the first thing I want us to do is to set our time picker. Now you go to dates and time range. The attack was conducted on 3rd of April 2026, 12:29 a.m. 12:29 a.m. And we are going to keep the difference so tight because the attack will not take that long. So let's do 12:33 a.m. When you're done with your date and time, depending on when you run the attack, you hit the apply. Then the first event code I'm going to start with is event code 1. I prefer starting my investigations with event code 1. So the first SPL we are going to investigate on is the event code 1. So let me run through what this code is all about. Our source is Sysmon operational logs. Now we are looking for event code 1. That's process creation. I prefer to start with event code 1. This lists all the process running in the system. If there is any malicious process or any unwanted process, I can easily have an idea of what the process is. So I'm piping it to a table format. This table format will have the time column, the event code column, the process name column, the parent process name column, and the command line that initiated the process. So let's proceed by clicking on the search button. By setting the time and date range, it helps you narrow down the search. Okay, we have our results. So what Splunk normally does, the most recent events appear on the top, while the oldest events appear below. So I love to reverse that. So you click on the time to reverse it. Now I have the oldest event on the top. From here, I can be able to put the events in a proper timeline. So let's see what's happening here. As you can see, the process name, Thunderbird, was executed. The Thunderbird execution gave birth to the unzipper file. When we open the Thunderbird and we open the phishing email via the Thunderbird, when we simulated it and downloaded the bonus file, which we had to click on the unzipper on the unzipper.bat. After we click on the unzipper.bat, It executed a PowerShell command, as you can see here. This command is actually the downloader that we created. So the downloader invoked a web request to our Calibus, our attack machine, on port 8000 and downloaded the any statements. After downloading the any statements as a test file, he wrote it to disk on the victim machine in the temp directory as any statement.bat, after which it executed the any statements. The following event shows that the any statement.bat was executed. So after the execution, you see this PowerShell script. If you can remember, this is the reverse shell payload that was downloaded. That's the any statement. It was executed, and then we had access to remote execution to our victim machine after the execution of this PowerShell payload. Going down, you can see other processes. You can see the enumeration command, the who am I enumeration command. This is a process that has to do with our edge because we are collecting telemetry from Splunk. You can see the IP config, the system info, the next stats. So that's pretty much what we can see with EventCode 1. After that, we will modify the SPL a little to accommodate EventCode 11, that's file creation. So what we are looking for is any file, anything that is reaching to the disk as event code 11 file creation. You can see this JavaScript file reaching to the disk, the process name that spawned the JavaScript is Thunderbird. So there are other processes here, but we are looking for any exceptional file, a strange file. You can see the enumeration command. This PS script policy, you notice that anytime there is a PowerShell execution, a PS script policy is created. That's because I have my PS script login on. Once you have your PS script login, every activity that occurs on the PowerShell will be saved in a directory which you indicated in your system. You can always go there to investigate further. So that's why you always see PS script each time a PowerShell execution occurs. Now this is our reverse shell script. Where the any statement was executed here. After the execution, the any statement, the bat was written to disk. This is an indication of compromise also. We go down. I think that's about it. Moving away from file creation, EventCode 11, we investigate further our network traffic. So let's search for EventCode 3 for any network connections. Nothing more changed in the SPL. Our operational is still our source, EventCode 3. Then I added the host, the processor, and the destination and the source IP. Let's search. So what I normally search for EventCode 3 network connection is to check if there are additional communication between the network and the attacker, or if there is a C2 communication back and forth between the victim machine and the attacker. So what we can see from this outcome is our PowerShell. What jumps out here uniquely is our PowerShell making some type of connection to 10.0.3.16. If you can recall, this is our attack machine IP, and 10.0.1.2 is a victim machine IP. So there is a communication, a PowerShell communication between the victim machine and the attack IP. So because for concern whenever a PowerShell is making a network connection, so we are going to investigate this IP 10.0.3.1 is an indicator of compromise. So after that, let's go back to event code 1 and 11. So from what we can see in this event code 1 and or 11, you can see the enumeration command, the system info, the IP config.exe, the who am I. These are enumerations. Usually they are not malicious processes, but a common user hardly make use of these commands unless it's an IT person who makes use of this command. So from here, by seeing all these three enumeration commands, you can go and investigate further. So what we can do, knowing that this is a phishing attack, we have to create a detection that we detect whenever these three commands are run within 60 seconds. Because what these attackers do, depending on their motive of attack, when they break in, regardless that we type these commands out, they normally automate this process. So after the attack, they go through the systems they have access to, check the ones that are domain systems, the domain joined ones. Then maybe they have initial access brokers. They can sell the information and access to a dark web. So what we do, we set a detection that detects whenever these enumeration commands are run. So to do that, we are going to use a special SPL query. This is a special SPL query that we're going to use in detecting the enumeration command, just in case we get attacked again. What's happening in this SPL is that our source remains Sysmon operational logs, process name in. These are the processes that we are filtering for. The UMI, the IP config, the system info, the net.exe, the net stats. All these are enumeration commands that adversaries make use of whenever they get into a new environment. So we are going to output the start values, the process name, we are going to output it as commands by time, the timestamp, and the host where the enumeration is run. Then the command count has to be greater than or equal to 2 for this detection to trigger. So let's run the detection. Okay, the outputs are here. These are the enumeration commands that have run in the last 24 hours. So what we are going to do is to save this as an alert. You can save it as an alert. You click on save as an alert. Yeah, you can give the title whatever you want. I just name mine triggered alerts. The description is optional. You can give you any description you like. You can set the frequency, how often you want it to run. Want it to run every week. Monday is left for you. You can set when it expires, maybe in 24 hours, 24 minutes, 24 days, whichever you like. Then you can put the number of results, trigger the alert when you can create a one-time trigger alert or for each result. Depends on you. So the trigger action is when you associate the alert with the type of action you want to be performed. Once the alert goes off, you can add it to triggered alerts, dashboard studio, snapshot, log events, Apple results to look up, Apple results to telemetry endpoints, run a script, send an email, whichever you want. Then you can save the alerts. But I'm not going to save this alert. I'm going to save it as new dashboard because in a SOC environment, the chief leads watches the dashboard whenever a triggered alert comes in. It assigns a SOC analyst to investigate it. So we are going to replicate that environment. That's what we're going to do right now. So we save this as new dashboard. The dashboard title would be all safe. That's the name of the managed security service provider Elliot works for. The description, I will leave that unattended to, but the panel title would be possible phishing enumeration. Okay, let me just put a description here. I think I'll just put phishing detection, phishing, I keep missing the H, phishing enumeration, detection. So I'll choose the classic dashboards. Then I'll save to dashboard. After saving the dashboard, I'll view dashboard. So in a SOC environment, the SOC analyst will be watching the dashboard. You'll be watching different panels, waiting for any alert to pop up. And once an alert pops up, you escalate it and assign it to analysts to investigate. Okay, we're just going to edit this panel and make it shorter. We reduce it to 3 per row per page. Now, any enumeration command that happens on our endpoints, it comes to this dashboard where the SOC analyst is always monitoring 24/7. So we can test this command by running the enumeration command. So let's just spin up our command line. So you can run the enumeration commands again. The who am I, the IP config, the system info, let's check on the dashboard. Let's refresh and check if it was captured. As you can see, it is 5th of May 2026. Time is 1:30 a.m. So these are the enumeration commands that we just executed, the UMI, system info, and IP config. They have been captured on the dashboard. So our detection is active and running. Now we have to move over to network traffic analysis because we captured the network packets during the attack. But before that, we need to stop imputing data because Splunk free edition has a maximum of about 500 MB a day. Once you exhaust that, some features will be restricted from you. So I have to turn it off. So let's turn off the data injection. Remove log collection. Disable. Click on disable. All right. The event log collections is disabled. Now let's move over to packet analysis. We're going to do the packet analysis with Wireshark. Okay, let me go to my downloads where I downloaded the packets. This is a context capture. There's the packet. I double click on it. I already have Wireshark downloaded and installed on my VM. So you can Google Wireshark and download the packet is opening. I will enlarge it. Here is our network traffic from the attack. So we apply a filter. If you can remember, we came across an IP. That's our attack IP. So we are going to filter for the IP. That's an indicator of compromise. So we just filter for communications from the IP. The IP address is 10.0.3.16. You hit enter. All the communication between our victim machine and the attack machine will jump out. Now we can see the SYN, SYNAC, and ACK acknowledgements here. So this means the connection was successful. After the connection was successful, a GET request was sent from our victim machine with the IP of 10.0.1.2 to the attack machine 10.0.3.16, and the download was successful. You can follow this communication. You can easily right click on any one of them, then go to follow. You follow TCP stream. As you can see, this is a phishing email. So the first connection was from our Windows. It sent a GET request over the protocol HTTP. As you know, HTTP is not an encrypted communication. So we can see the plain text. And here is where the payload was downloaded. As you can see, the PowerShell payload. Now we have a better understanding of what happened. Yes, we can close the tab. X the add the filter. We apply the filter. So after the first scene, you can see another scene arc connection. So we click to follow the TCP stream. Okay, as you can see, this is the communication between the attack machine and the victim machine. These are the enumeration command that we run from the version mounted on disk E, the who am I, and you see the response equal pre-price, the IF config, the system info, and the results. This is just basically the communication between the attacker and our victim machine. So that's pretty much what we can come up with, analyzing the packet capture. It gives more context to the attack. So this will do it for us. In the next video, we switch over to red team, where we will establish a system mechanism by deploying our C2 command and control. And then you will see how the IP address will change from the attack machine to the C2 command and control IP address. So make sure you watch the next video that will be uploaded soon. That's it for today.